Hello, I'm Farai and this is my code lab. Today, we're continuing with CTCI. So for the past 2 days, I've been flunking big time, but hopefully I can turn things around today with 1.8, where we have to write an algorithm such that if an element in an m by n matrix is 0, its entire row and column are set to 0. So, let's start with an n by n. So 1, 3, 0, 1, 5. So given this, then our matrix should look like 1, 2, 1, and 3. No, it should be like 1, 0, 1, and 3, 0, 0, 0. Right? Because we need to zero out its row and column. Wait. Such that if an element in an M, its entire row and column are set to 0. So this one, thought of like just zeroing out as you go, but I think that would, like, what happens if you're like continuing and wait? Because I was just thinking the issue could be like, what if it's like 0, 2, 4, 3, 1, 0? Then you look at an element, it's like if it's 0, then you zero out. Then if it's 0, but then that would just be everything is 0. So I won't just do it as you go. I will just mark the zeroed columns and rows. So if an element has 0, then you just mark that it's 0. So you just take a note of its row and column. No, you just track the 0 row and call, right? You just store it. So function and then I think, yeah, function 0 matrix. Let's call it M. Right? Then 0 rows, 0 calls. These are arrays. Right? Then for let I equals 0, I is less than and length, then I plus plus, then we do for let j equals 0, j is less than m0 dot length, then j plus plus. Then what we're doing is, oh shoot, set? Yeah, sorry, I'm just thinking these should be sets. Set. Yeah, I mean, I hope you don't ask me to implement a set because I'm not doing that. Oh, just as I'm speaking, the 1.7 video, which I failed, is online. So, okay, now, if j, if m I j is equal to 0, then zeros, then 0 rows dot push I don't think I need a set really, but we can just discuss that later. 0 calls dot push j. All right. And if it's 0, you just push a row and you push the column. Then afterwards, oh boy, this is where all the work starts. For row of row of 0 rows, so that would be so let's go 1 3 2 0 0 4. So the rows, that would be 1 comma 2, right? Then we need to zero them out, so that means for I equals 0, I is less than m row dot length, could just be m0, there's no difference really, then I plus plus, yeah, for row of works because the row is a number. So then we do m row I is equal to 0. Ish, the columns now. For call of 0 calls, right? For I equals 0, I is less than and length. Since we're going down, then I plus plus, then m I call is equal to 0, then return m, and yeah, that should be it. So let's try it out with this here. So okay, so we have our array. Yeah, we have our array. So then for I, okay, so let's go. I is 0. J is 0. Then 1, no. And ZR, ZC. So those still empty. So 1, 0, 1. So nope. So then 1, 0 would be if mi is 1, 0 is 0, no. But then m1, 1, that means we are going to push 1 and 1, and with 2, 0, then if m2, 0 is yes, so then we are going to push But remember, it's a set. Yeah, it's a set. So 2, 0, and 1, 1, and then push 1, and J, push 2. So there'll be 1, 2. 1, 2 in rows, and then the columns are 1, 0. So now we have these then for each one in here. So then for each of the rows, so 1, 2, then we're looping through that. Then we're going to go from 0 up to length. So so R and I. So if R is 1 and I is 0, then that means our new matrix here is 1, 0 is 0, and then row is still 1, so 0. No, it's not 1, 2. It doesn't. Yeah, it kind of. It doesn't matter. So actually, no. Let's go back. 1, 1. So it's 1, 2, and 1, 0. So we have our R. So our R is 1 and I is 0. So that means that. So then 1, 0 up here. 1, 0. So that means our matrix should be 0, right? Then 1, 1 is 0, which it already was. 1, 2, which is 0, right? Okay, and C and I. Shit. Oh, crap. Wait, hey, shoot. Let's go back a bit. I'm sorry, I've lost track. Let's go to 1, 1. So 1, 1 is 0. So the 0 column is 1. 0 row is 1, and 0 column is 1. And then 2, 0 is here. Oh, shoot. I was actually right. I just didn't know the dimensions of the matrix. So 2, 0. So then here in 1, 2, and the column here, row, oh yeah, and yeah, my algorithm won't work. No, it will. Because that 3 would be shoot. Because you'd have to go like here. You have to go from there and there. And then there and there. Yeah, that's zeroing out. So let me pick a better example. I'll pick a better example, then we look at the tips. So I suspect I'm on the verge of something good here. So let's pick 1, 2, 3, 0, 4, 2. Right? So theoretically, we would expect this and that to be 0 and the rest to be untouched. So let's try that out. So I, and then j, and 0 row, and 0 column. So I is 0, j is 0, 0, 0, no, and 0, 1, no, then 1, 0, no, 1, 1, so 1 and 1. One and 1, and then 2, 0, still 1, 1, and 2, 1, still 1, 1. So you just have 1 and 1 in here. So you go from R and I. So the row is 1, I is 0. So then our resulting matrix, sorry for pencil, I'm too late. I'm not going to switch that now. So R1 and 0 is 0, right? Then R1 and 1, 1 is also 0, right? And then we go C, I, right? And then C, there's 1, 0. That makes that 0. Then 1, 1, which is already there. Then 1, 2, which is down here. And then 1 and 4. So yeah, that looks like it works. I'm going to look at the tips here. So tip number 17 says, if you just clear the rows and columns as you found zeros, you'll likely wind up clearing the whole matrix. Try finding the cells with... Yeah, that's what we did. That was kind of what I was pointing out at earlier. So then 74. Can you use n space instead of n squared? N space. Okay, this is an n squared runtime because you're going through every row and column. Right? So it's asking if we can use n space additional. Can you? 102. You probably need some data storage to maintain a list of rows and columns that need to be zeroed. Can you reduce the additional space usage to 0 to O of 1? N squared. It's saying you can use n squared, constant additional space instead of n squared. So like not making the matrix again. Yeah, we just did that. But then probably need. Can you reduce the additional storage space to constant by using the matrix itself as storage? I think it is possible. But then you're looping it twice, right? Just thinking, like if you turn this 0 into a null, right? And then find the nulls, and then you go up, and you 0 it, and then you go across and 0. That should do it. I'm gonna try that. So let's just copy all this first. There we go. All right. Yeah. So for one, I doubt we'll be needing this anymore. So let's. Yeah, we don't really need that. So what I'm going to do is I'm going to loop through it twice. So so if Mij, then Mij is equal to null. Okay. All right, so then, oh no, this will kind of be terrible. Because there's one n squared. But let me just write it out and then finish earlier. So for n equals 0, is less than m dot length, then a plus plus, right? So for j equals 0, j is less than m0, j premium. What we need to do now is if, oh dang it, if everything's null, then this is, oh my god, this would just be n cubed. No, not even cubed, n quad. Once after cubic, it'll be n quartic. Yeah. It'll be a fourth order polynomial, basically, if everything is null. It's doing 4, 4, 4, 4. So you can, but I won't pursue that option. So I won't pursue that option because a quadratic function isn't very fourth order polynomial function isn't really my cup of tea. Unless there was another way to use the matrix as storage, but that's trade-off between space and time. So let's look at what the answer is. I'm committing what I have, so let's head off to the solutions and zero matrix. First, this problem seems easy. Just iterate through the matrix, and every time we see a cell with the value 0, you set its row and column to 0. There's one problem with the solution though. When we come across other cells, then they will also be 0, so everything will just be 0. One way to do this is to keep a second matrix with the 0 locations. We'll do that. We'll then do a second pass through the matrix and 0 it. Yeah, that's what we did. Do you really need M event space? No. Since we're going to set the entire row and column, don't need to track exactly what cell. Do you really need M? No. Since we're going to set the entire row and column to 0, we don't need to track that it was exactly the cell. We only need to know that row 2 has a 0 somewhere and column 4 has a 0 somewhere. We set the row and column to 0, so why should we keep the exact track of? Wait. Pass. Okay, we keep a flat second matrix. Oh no, that's what I did. No, we're going to set the entire row and column. Uses 2 arrays to keep all the zeros. So. Yeah, that's pretty much what I did. Yeah, that's literally what I did. To make this more efficient, we could use a vector instead of a Boolean array. It will still be n space. We can reduce to constant by using the first row as a replacement for the row array and the first column as a replacement for the column array. This works. Can reduce to constant space by using the first row as a replacement for the row array and the first column as, so that works as check if the first row and first column have any zeros and set the variables row has 0 and col has 0. Oh, okay. Iterate through the rest of the matrix. Okay, so we'll check. This code has a lot of do this for the rows, then equivalent action. In an interview, you could abbreviate this code by adding comments and explain that your next chunk of code looks the same as the earlier, but using rows. This would allow you to focus on the most important parts of the algorithm. Yeah, because this is a lot of work. So, okay, so if I get them right, so look at me trying to draw with an eraser. So 1, 2, 3, 0, and 4, 2, right? That was our example, okay? So first we check if the first row and column have 0, so, and set the value row as 0, column as 0. I don't quite understand this. I wonder, can we finish this chapter today? So we check the first row and iterate through the array, setting I0 to 0 whenever there's a 0. Right, so you check if there's a 0 and 0. So 0 is false, and C0 is false, right? So these two are false. Then we iterate through the rest of the matrix, setting I0 whenever there's a 0 in. Shoot. Okay, check zeros throughout the rest of the array. Okay, so we could just pretend this isn't a thing, right? Do the rest of the matrix, right? And then I would be 1, 1 if it is 0, right? If it is 0. Then if it's 0, then we just, so then the next thing we do is R2 is 0, so the column, 0 row, 0 column. Actually, we'll finish this chapter tomorrow. So 0 row, 0 column, right? Then what this does is, if it is, then we just put a 0 at the end of the one row and a 0 at the end of the other column, right? And 0 at the other column. Because I is 1, 2. But the rows are going to be 1, 2, and columns is just 1. Then 1, okay, and then 2, 1. That stays. Okay, I see. Okay, I see. So then you loop through, right? And then, like, once you've gone through all that, you loop through. If there's a 0, you just nullify all that. And if you come across a 0, you nullify all that. So that makes sense. Yeah, that's quite a nifty solution. Wait, isn't my null thing just doing the same thing? Yes, it is. Really? I mean, look. Okay, so oh yeah, it is doing the same thing, but it's n cubed, but this one is n squared at most. So yeah. Alright, I'm gonna end this here now. I think the next one, the 0 rotation, will, because wow, this one, it needed quite a bit of creativity. I would have never really thought of a solution like that. So yeah, tomorrow we're doing string rotation, which is so we're gonna see if something is a subset. So yeah, assume you have a method substring which checks if one word is a substring of another. Assume you have is substring. Okay, yeah, assuming you have an is substring, so that part is taken, which checks if one word in a string is a substring of another, and code to check if S2 is a rotation. Yeah, we'll think about this tomorrow. So yeah, finally, third time's the charm, as they say. I've succeeded this one. And yeah, thanks for watching, and I'll see you... Wait, no, I'm not signing off yet. Additional questions are object-oriented design, recursion, sorting and searching, C++, moderate, and hard stuff. So yeah, this is small fries. Haven't even gotten to the big stuff yet. So yeah, thanks for watching, and I'll see you next time. Just close. No.